Hi gents, we're going to do some simultaneous linear equations here. I have given an assignment to do on build-up, and that assignment is going to be part of your summer grade. So please make sure that you have a look at this little video first before trying it out on that one. You can actually, on build-up, you can try it a few times. So what you should be doing is you should, if you don't get the grade that you want at the beginning, you can actually just give it another roll. That's going to be in by Wednesday. I think it's the 6th, 6 p.m. So just have a little look at this and just remind yourself how to do it. Okay. So let's start off with a simultaneous equation. X plus 2y is equal to 7. Let's actually just start off with one equation first of all. We just have a little bit of a chat about it, just so we definitely understand what's going on here. In this case, what we're saying is one number plus 2 times another number is 7. And you might say, what would x be and what would y be? So for instance, if you made y 3, so you would have 2 by 3 there, which is 6. X would have to be 1, for instance. But what if you made y2? What if y was, is that the only possible answer? And clearly it isn't, because if you make y2, 2 by 2 is 4, so that would make x 3. And all of a sudden, there are now 2 sets of answers. And in fact, if you make y1, you'll have 2 by 1, which is 2, so x would have to be 5. In fact, you could make y 0, in which case x would have to be 7. You could make y equal to minus 1. If you put in that, you would have something added to 2 times minus 1. 2 times minus 1 is minus 2. So you've got something minus 2 is equal to 7, and the something must of course be 9, which kind of fits the pattern that's been going along here as we do it. So the point is that with that equation, there are an infinite number of answers. And in fact, I might just leave some of those answers. So I don't know, will one of those answers be the answer that works for this, but I'll just leave them up just in case. Because the example that I have is x plus 2y equals 7, and it is 3x minus 5y is equal to minus 34. Maybe it won't be one of these, who knows. What's the point here? The point here is that there are also an infinite number of solutions that will fit into that equation. But with simultaneous equations, what you're finding is the value of x and y that work in both equations, in equation 1 and equation 2. Okay, so the way in which you solve this is you want to add the 2 equations together in some sort of fashion. Now, if I take 2 equations, like 1 plus 2 is equal to 3, and if I take another equation like, 5 minus 2 is equal to, well, it's also 3. If you add those things together, if you add the left-hand side, if you add the numbers that are over here, what you'll get is on the top, for instance, if you were to do it like that, you would get 3. On the bottom, you would get 3. Well, of course you do. They're both equal to 3, as we know that. But even if you were to add just going down the way, if you add 1 and 5, you get 6. And when you add 2 and minus 2, you get nothing. Well, of course you get 6 in total, because each one of those lines was 3. So when you added them together, you get 6. But the point is that you can just add going down the way. In each case, you will still end up getting a truthful answer. So that's what we want to do here. We want to add them together, but we want to add them such that it gets rid of either an x or a y. So in order to do that, if you had, for instance, 3x, what you would want to be adding to that is minus 3x, because that would create 0. Okay, so that's one possibility. So what you could do is, with that first equation, because it's an equation, if you have like 1 plus 2 equals 3, if you, for instance, multiply every single term, or maybe best think of it both sides, let's multiply both sides by 4. Okay, but when you multiply by both sides by 4, when you have just things being added and subtracted, it means that you've got 4 1s added to 4 2s. It's the same as having 4 3s. That is true. 4 plus 8 is 12. So that's what we're going to do. We're going to take that first one, and we could multiply each term by, well, to get minus 3, we'd multiply each term by minus 3, because it would get us minus 3x. Okay, but actually I'm not going to do that one. Even though that's the faster way to do it, I would do that if I was in an exam, just to show you, because that option won't always be available. Let's try and get rid of the y's. Okay, we've got 2y and we've got 5y. Now, we'd like to multiply 2y by something to get 5y. You know, if you had plus 5y here, when you add them, then you would be sorted. The y's would you know, give you 0, so they disappear, if you want to think of it like that. Now, there is a number that you could multiply by, but it's not the most obvious number in the world. So what we try to do is we try to look at what's the number that we could, what's the smallest number that we could both multiply these things up to. Another way you can say it is, what is the number that will that both these numbers will divide into? So one way to get it for sure is to multiply them, but you can see here that we can multiply up to make them 10. So if you multiplied that first line, what would you need to get 10y? Have a think. You multiply by 5. So everything in that first line, everything multiplied by 5. 5x plus 10y is equal to 35. And then in the second one, remember, we now want minus 10y, so that we can add them together and get nothing. So you would multiply by minus, nope, not minus, multiply by just 2, I beg your pardon. So that second line by 2, 6x minus 10y is equal to minus 68. And now we're good to go. Now we can do our adding down the way. So we can just add 5x and 6x, gets us 11x. Plus 10y added to minus 10y, that's nothing. And that was the whole point of doing it. Okay, the whole point was that we would get rid of either the x's or the y's. And 35 minus 68, you can just type it into a calculator if you want, is minus 33. So now we have an equation where there's only one thing that we don't know. 11 times a number is minus 33. What is the number? Well, you should know that in your head, but if you didn't, you could divide both sides by 11. And 11x divided by 11 is x, that's why we divided by 11. And minus 33 divided by 11 is minus 3. Don't forget, you also want to find out what is the y value. So the y value that you are looking for can be got by substituting into either 1 or 2. And I think it's easier just to multiply, or just to put it into x plus 2y equals 7. We'll place it in there. So we get minus 3, that's what x is, plus 2y is equal to 7. Add 3 to both sides. We added 3 to the left, we just get 2y. We add 3 to the right, we get 10. And now we divide both sides by 2. So we get that y is equal to 5. So there we have it. We have x equals minus 3 and y equals 5. And what does this mean? This is the solution that works in both equations. So it actually wasn't one that we had found there. Now, we did say there was an infinite number of them, so the fact that we only tried and found 5 of them doesn't mean that, you know, we'd done anything wrong or anything like that. Well, we'll just double check it. X plus 2y, what was it, equals 7. And the other equation was 3x minus 5y, a little bit harder to check this one, is equal to minus, what was that, 34. Well, here's our quick check. Okay, if x is minus 3, added to 2 times, I'll make that clear, y, which is 5, is that 7. We'd get minus 3 plus 10, giving us 7. Well, that's true, yeah, 7 is 7. So that solution works for this one, and it should also work for this one if we haven't done anything wrong. So it's 3 times minus 3 minus 5 times 5 is equal to minus 34. So we get minus 9 minus 25 equals minus 34. Is that true? It is true. So we are all good to go. Okay, there is your example. I'll make out another video, perhaps with another few examples. But just to maybe leave you with some idea of what you might have to do if it's not written out exactly the way you would want it. Like, what happens if the question is 2x minus y equals minus 3. That's the first equation, all fine. And the next one is x equals 2y minus 3. What happens if it's like that? That's the second equation. In this one, you need to do some work first of all. So I suggest that you write it as x's, y's equals number. Whereas here you've got x's equals y's and number. So if you want to have x's, y's equals number, the y's are the problem here on this one here. So for this second equation here, what you should do is you should subtract 2y from both sides. That will get you x minus 2y is equal to minus 3. That's still the second equation, and you will have the first equation, which is 2x minus y equals minus 3, still to work with. And now they're all set up perfectly to go. In fact, pause it here and use this as maybe a little homework question just to try out, and I'll give you the answer now in just a second. Okay, so hopefully you attempted that particular question. Now, what do we want to do? Do we want to get rid of the x's or the y's? You know, they're both equally as difficult. Let's say we want to get rid of the x's. Here we've got 2x, so we want beside it, if we have plus 2x, we want to have a minus 2x. So we take that second equation and multiply by minus 2. Because minus 2 by x is minus 2x, just what we wanted. Everything else by minus 2 as well, you can't just take one of them. Plus 4y, it's minus 2y by minus 2, that's plus 4y, is equal to 6. And we're adding that to 2x minus y is equal to minus 3. That's the first equation. It doesn't matter if you add the first to the second or the second to the first. The order in which you add things doesn't change the value. So what do we get? We get minus 2x plus x, which is nothing, just what we wanted. 4y minus y, which is 3y. And 6 minus 3, which is 3. Well, 3 times a number is 3. That number is obviously 1, but if you didn't know it, you divide both sides by 3. So you just get y is equal to 1. And then we sub it back into any one of our equations. I think I'd sub it back into, well, actually, yeah, I suppose, into equation 2. X minus 2y equals minus 3. Remember, y is 1. So we get x minus 2 is equal to minus 3. Add 2 to both sides. Add 2 to the left. We just get x. Add 2 to the right. We get to minus 1. So we get x equals minus 1. Y equals 1. And you know what? No bad idea. Just to double check what we were dealing with, we had 2x minus y equals minus 3. X minus y equals minus 3. And we also had x equals 2y minus 3. X equals 2y minus 3. So just a quick double check. Does minus 1 work? So 2 by minus 1, that's minus 2. Minus y, which is minus 1. Yeah, equals minus 3. That works there. Does it work down here? Is minus 1 equal to 2 by 1? That's 2 minus 3. Yes, it does. It works there. This is our answer. Hopefully now you're able to do that, and that was your homework done out of the way. And you should now be heading over to build up in order to do the assignment that I've left there. Remember, it goes towards your summer grade, so and that you can have another shot at it as well. Like if you do badly in the first one, it allows you to resit it straight away or come back to it. Anyway, I'll have a look at what you've done by Wednesday at 6, and we'll take that one as your grade. So thanks for being, gents. All the best.